You know when you open your favorite app and a whole feed of new posts just appears? Ever wonder how that actually works? Well, today we're going to pull back the curtain on that little piece of magic. We're going to demystify the GET request, the absolute core command that powers how we get data on the web. And we'll see exactly how to handle it using the super popular Express.js framework. So let's dive right in. So let's start with a question that sounds simple, but is actually pretty deep. When you open any app, social media, shopping, whatever, how does all that information show up on your screen? It feels instant, right? But it's not magic. Behind the scenes, there's a really specific, well-designed process that's making it all happen. And the answer to that question is the HTTP GET method. You can think of it as the universal command for go get me this information. It's a huge cornerstone of what's called REST architecture, which is the design philosophy behind basically all modern web APIs. And in that world, the GET method has one job and one job only, to read data. It never, ever changes it. Okay, so what makes GET so reliable and so essential? Well, it comes down to two core principles. I like to think of them as its superpowers, because they guarantee that things are going to behave predictably and efficiently every single time. Let's break them down. And these two superpowers have names, safe and impotent. Safe just means the request won't mess with anything on the server. And impotent means you can make the request once or 100 times and you'll always get the exact same result. So let's see what that actually looks like in practice. First up, safe. Now, this is a crucial guarantee for any developer. Making a GET request is a lot like looking up a word in a dictionary. You get the information you need, but the dictionary itself stays completely unchanged. This means you can fetch data without any fear of accidentally changing or, deleting something important on the server. And its partner is idempotent. This is an incredibly useful property. Think about pressing an elevator button, right? Whether you press it once or you mash it 10 times, the result is exactly the same. The elevator gets called. For a GET request, this means if your network connection drops and you have to retry, you can do it without causing any weird side effects. You'll just get the same data back, which is exactly what you want. Okay, so that's the theory, but how do we actually handle these requests in our code? This is where a framework like Express.js just absolutely shines. Let's jump into some code and see how these concepts are brought to life. In Express, the pattern is just beautifully simple. app.get. This method takes two main things. The first is the path, which is just the URL you want this code to respond to, like /users or /products. The second is the handler, and that's just a function that's going to run whenever a request hits that path. So, a classic Hello World example takes just 3 simple steps. First, we import the Express library. Second, we define a route for the route path, which is just that / you see there. And third, we give it a handler function that takes a request and response object, and we use res.send to send back our message. And boom, just like that, you have a working web server. But let's be real, most of the time, we aren't just sending simple text. Modern applications all speak a universal language for exchanging data, and that language is JSON. And Express has a fantastic built-in way to handle this for us. Yeah, this slide highlights a really key distinction in Express. You can see we have 2 methods, res.send and res.json. Now, res.send is this flexible, all-purpose tool for sending text or HTML. But res.json is the specialist we need for APIs. It does 2 critical things automatically. It turns our JavaScript data into a JSON string, and it sets the correct content type header, basically telling the browser, hey, what I'm sending you right now is JSON. We can make our responses even more robust by chaining methods together. As you can see here, we're adding .status 200 before we send the JSON. That 200 status code, it's the universal signal for, okay, everything worked perfectly. We could just as easily send a 404 if the data wasn't found. Explicitly setting these codes is just good professional practice because it gives the client clear, machine-readable feedback on what happened. All right, theory is done. Code basics are done. Let's put it all together in a complete practical example that's just a little bit magical. We're going to build an API endpoint that serves up a list of wizards. First things first, we need some data. Now, in a real-world app, this would probably be coming from a database, but for our example, a simple JavaScript array of objects is absolutely perfect. As you can see, we've got a couple of wizards, each with an ID and a name. This is the information we want to make available through our API. And here is the code that makes it all happen. It really shows off the simplicity of Express. We define a GET route for the path /wizards, Then inside our handler function, we just call res.status200.json and we pass in our wizards array. That's it. Express handles all the heavy lifting for us. And this is the final result. This is exactly what a client, whether it's a web browser, a mobile app, or even another server, would actually receive. It's clean, it's structured JSON data, and it's super easy to work with. We've successfully gone from a simple data array on our server to a fully functional API endpoint. So let's just quickly recap the key takeaways here. At its core, the GET request is our safe, reliable, and repeatable tool just for reading data. In Express, we use the simple app.get method to connect a URL path to some data. And when we send that data back, res.json is the professional standard, making sure any app can easily understand our API's response. So now we've totally mastered how to get data from a server. But that's really only half the equation, right? The next big question is, how do we create new data? How do we send information to the server? Well, that's where the post request comes in, and we'll explore that in a future explainer. Thanks for joining me today.